Alright, so how do you do this type of problem? Well, it's the same idea. Except for you see how you can't really get all of the square roots by themselves here. Because of that 2 on the right side, and because there's 2 square roots. So we're going to do the next best thing. We'll get one of the square roots by itself. So, doesn't necessarily matter which one. I'll just go ahead and keep that one, and I'll add the other one to the other side. And then you just got to square both sides. You got to square both sides to get rid of the square root. You just have to be really careful when you do that, because you're going to square both sides here, and you're going to square both sides here. So what ends up happening? You get 2x plus 3, because the square root just goes away. They cancel each other out. But then you've got to square both sides here. You got to actually multiply this by itself. So that can be kind of tough. Well, not kind of tough, just tedious. But what do we got? So we got the 2 times the 2, that's the 4. And it's really just the squared thing pattern again. So you get the first thing squared, which is the 4. And then you're going to have the last thing times itself. So just x plus 2. And then the first thing times the last thing times 2. So in this case, 2 times 2 is 4. And then square root of x plus 2. So that's what we end up with now. So see how, just because that's how it worked out, we were not able to get rid of both of the square roots in one go. But that's fine, because see how now we just have one square root. So now if we get everything to the left side, we will be able to get rid of that square root by squaring both sides. So let's go ahead and do that. Let's subtract the x to the other side. So then we just have a plain x. And then we have 4 plus 2, which is 6. And then we'll subtract that to the other side. So x minus 3 on this side equals 4 root x plus 2. And now you have some options. I mean, it doesn't matter. We can square both sides now. Or we can continue with our ideas. Let's get the square root by itself. It doesn't really change much. The key thing is that when we square both sides here in this step, we've got to be sure to square that 4 as well. That's the key thing. So let's see. We square the top. So let's use our pattern again. That'll be x squared, then 2 times 3 times x, so minus 6x, plus 9. All that'll be divided by 16. And then over here, now the square root's gone away. So you see now we just have a quadratic. So our best bet is to multiply both sides by the 16 to just get it in one line. So this stays the same. And this I'll go ahead and distribute. So 16x, 2 times 16, 32. And then now let's set it up to factor. So let's move everything to the left side. X squared minus 22x. 9 minus 32, that's like 32 minus 9. That's like negative 23. And then again, that's a complicated looking factor, but it's not. It's x minus 23 and x plus 1. 23 is, what do you call it, semi-prime? So there's really only one option. Or no, it's just prime, so there's one option. So what is that? Our answers of negative 1 and 23. And again, remember, we've got to plug those in and make sure they work. So let's see, if we plug in 23, you get root 2 times 23, 46 plus 3 minus root 23 plus 2. Does that equal 2? Well, 46 plus 3 is 49, so the square root of that's 7. Square root of that's 5. So that does indeed work when you plug in 23. What was the other one? Negative 1. So let's see. When we plug in negative 1, we have root 2 times negative 1, negative 2, plus 3, minus root negative 1 plus 2. That's just 1. And we're saying, does that equal 2? What do we get? This is root 1, so that's 1. So we're getting 1 minus 1. Does that equal 2? No, it does not. So negative 1 is not good. 23 is the only answer. Very important that you check your answers here. That's easy to forget, but it's very important.